Now we look at the equation of a plane in R3, and for that we're going to recall the equation of a line in R2. So remember that we have constructed the point normal form of a line by saying that a line can be specified by a point on the line, which we call P0 or P0, and a vector that's perpendicular to the line. So this is making a right angle with our line. Now, if we're given another point P, P on the line, there we go, P, the equation of the line is given by the fact that the vector going from P0 to P, so that vector here will make a right angle with n. So that means that the dot product of these two vectors is going to be equal to 0, and by doing that we calculated P0P, that's x minus x0, y minus y0, dot product with AB, and we got the point normal form for our line. Okay, now for planes, imagine I have a plane now, so planes, I'm going to write it just next to it because there's a strong analogy between the two, between lines in R2 and planes in R3. If I have a plane in R3, imagine, okay, this is, the plane stretches in all directions, but I'm just going to draw a portion of it. So imagine this is the plane, right? Okay. So I can define it by, if I give you a point on this plane, okay, so I'm in R3 now, so I'm going to have three components, x0, y0, z0. And if I give you a vector that's perpendicular to this plane, ABC, if you think about this, it completely specifies what this plane is. There's a unique plane that passes through P0 and that's perpendicular to n. Cool. So this makes a right angle here. So if I have another point P on the plane, let's say with coordinates x, y, z, okay, and now I look at the vector going from P0 to P, it makes a right angle with n. So this is a way of characterizing any other point P on the plane. It's such that P0P is a vector that makes a right angle with n. So the dot product of the two vectors is going to give me 0, and if I do this, well, I'm going to get exactly what I have on the other over here. I'm going to sort of repeat the computations I have here, but by adding an extra component. So all I'm going to get is this. y0, z minus z0, that's P0P, dot product with n, ABC equals 0, and if I expand this, I'm going to get A times x minus x0 plus b times y minus y0 plus c times z minus z0 equal to 0. So this is also the point normal form, but for my plane. So in some way, the generalization of this equation here to R3 is a plane. So you could argue that when you extend the concept of a line in R2, it gives you a plane in R3. But of course, that depends on the type of equation you consider. So if you consider a point normal form, that's true. If you consider vector forms, when you extend the concept of the vector form of a line in R2 to R3, it's still a line. But for point normal forms, when you extend the concept, you get a plane. So maybe, so this is point normal form right there. But of course, you could always expand this, right? If I expand everything, I'm going to get AX plus BY plus CZ, okay? That's going to be equal to AX0 plus BY0 plus CZ0. And that's just a constant here, okay, which you could call maybe not C, D. So when you have an equation of the form AX plus BY plus CZ equals to a constant D, or if it's, sometimes it could be written like this, the D could be on this side, because switch this d over here becomes minus d. Now rename minus d anyway. So so any equation of this form or this form, okay, is going to be the equation of a line. Okay. So for example, if I have 2x minus y plus 3z minus 1 equals 0, okay, I can describe what kind of plane this is. Okay, well, first of all, the coefficients of x, y, and z, actually the coefficient of y is going to be minus 1, okay, because this is plus minus 1y. The coefficients 2, minus 1, and 3, okay, those correspond to my ABC. And ABC over here, right, remember, those are the same ABC that I have here. So those are the coordinates of a vector that's perpendicular to my plane. So therefore 2 minus 1, 3 is perpendicular to the plane. I could easily find a point that passes through this plane, that belongs to the plane. The point, how do I find a point that's on the plane? Well, all you have to do is assign your favorite values to x, y, and then you solve for z. So for example, if I let x equals 0, y equals 0, well, what do I get? I get 3z minus 1 equals 0. I get 3z equals 1. So I get z is 1/3. So the point 0, 0, 1/3 is a point on the plane. Of course, you could assign your favorite values, right, to x and y. It doesn't have to be 0 and 0. I choose 0 and 0 because it's a lot easier. But you could assign 12 and 16 and solve for z, or you could assign y a value of 6, z a value of 4, and solve for x. Okay, but usually if you can assign as many zeros as you can, it makes things much easier to calculate. So what I have here is really I've got my n and my p0. So this is a plane passing through 0, 0, 1/3 and perpendicular to n, which is 2 minus 1, 3. Maybe another example, find a plane passing through 1 minus 1, 6, or 5, doesn't matter, and perpendicular to I don't know, 1, 2 minus 4. Okay, find what I want to find the equation of a plane. So how do I do this? Well, this is my n. This is p0. Okay, so all I need to do is write it in point normal form. So it's 1 times x minus x0 plus b being my 2, times y minus y0 plus c times z minus z0, z0 being 5, equals 0. And of course I can write this in a much nicer way, so plus 2 times y plus 1 minus 4 times z minus 5 equals 0, and that's the equation of the plane. If I expand it, I'm going to be able to write it. You see, I could expand it and write in the form ax plus by plus cz plus d equals 0. What would that give me here? Minus 1 plus 2 plus 20 equals 0. So if I regroup my constants, this is plus 21. Okay. So you see, you could have the constant there, or I could also send a 21 on the other side. It would give me minus 21. If I switch it to the right hand side, it doesn't matter. So I can write it also this way. I could write it that way. Those are all good. Okay, but if you want to be efficient, you stop there, because you're asked to find an equation. It doesn't have to be in a specific form. So here we go. You leave it like that. Okay.